Hi guys, it's me, Mr. Miller again. We're doing Chapter 6, Section 2 on speed and velocity. So let's get started. So what is speed? Well, speed is defined as the distance an object is going to travel over a certain period of time. That equation is going to be speed equals distance divided by time, and that's what that means down here. S equals d over t is S equals distance divided by time. Now your distance can be expressed in either meters, kilometers, centimeters, millimeters, or if we use other units, feet, inches. We can also use miles, but in this class we're going to focus with meters and centimeters and millimeters. For time, we're going to typically use seconds or hours. And there's our equation. You'll want to memorize this, star it, highlight it, whatever you need to, because we're going to need to know it for tests. Next, what are some of our common SI units that we're going to use? Well, for distance, the SI unit for distance is known as the meter. And some of the units for speed are going to be meters per second, kilometers per hour, feet per second, or miles per hour. And these are just some things that we need to be familiar with that we'll be using here in our labs or out in real life. Now, what about a speed practice problem? Oh yes, we get to do some math work here in science again. And just like any other math problem, there are certain steps you got to follow for each problem. So the first one says Mike travels a distance of 18 meters. It took Mike 9 seconds. What is Mike's speed? Well, just like we did before, you always put S equals question mark. Well, this is because we don't know what speed is. That's what we're trying to find. Then we'll want to put the equation, which is S equals d over t, which stands for distance divided by time. Then you want to go ahead and list out what each one is. So d stands for distance, and that is 18 meters. T stands for time, and that's 9 seconds. Now go ahead and plug it into your equation right here. So S equals 18 meters divided by 9 seconds. Show me your long math work over on the side. So you got to show me the long division. Double check with a calculator, and then you'll get this answer down below. S equals 2 meters per second for his speed. Circle the final answer. All right, that's how you do a speed problem. Now, average speed is just a little bit different than speed. Average speed is the total distance traveled divided by the total time it takes to travel that distance. So AS for average speed equals total distance divided by total time, TD over TT. Memorize that one too. Typically for this, what does that mean? It just means I'm giving you multiple distances in multiple times, and we need to figure out what is the average speed over that period of time. So let's do an example. Here's an average speed problem. Tom drives 6 kilometers during the first hour of his trip. Then Tom traveled 8 kilometers during the next hour of his trip. What is Tom's average speed? So Tom didn't travel the same speed during his trip, so we need to figure out what is his average speed. So again, we write AS equals question mark, which stands for average speed. Then we plug in our equation, which is this right here. Average speed is total distance, you can abbreviate TD, divided by total time, TT. Now plug in all your information. What was the first distance he traveled? Well, that's going to be labeled D1. That is 6 kilometers. What is the second distance he traveled? Well, that was 8 kilometers. So put D2 equals 8 kilometers. Now, how long did it take him to go that first distance? Well, according to our problem, it says it took him 1 hour. During that first hour, which means 1 hour, so T1 becomes 1 hour. How long did it take him to go the next distance? 8 kilometers during the next hour of his trip, so another hour. So T2 equals 1 hour. Now plug in your numbers. Here's an extra step. AS equals 6 kilometers plus 8 kilometers. 1 hour plus 1 hour. So when you add those up, you get AS equals 14 kilometers and time equals 2 hours. Now go ahead and divide. Show me your long math work, long division, 14 kilometers divided by 2 hours. And your final answer is an average speed of 7 kilometers per hour. And you circle your final answer. So really the only difference with average speed is I'm going to give you more than one distance and more than one time. And you just got to total them up first before you divide. That's really the only difference. For most of my problems, you'll see probably 2 distances 2 times or 3 distances 3 times at the most. Okay? All right, moving on to velocity. So what is velocity? Velocity is very similar to speed. It is just simply speed in a given direction. The only difference with velocity is we've tacked a direction onto the end. Now, you got to have both the speed and the direction to know velocity. If you don't have the direction, then you don't have velocity, you just have speed. All right, so take a look at our airplane there. Its speed is 300 miles per hour. But if I want to turn that into velocity, I simply say we're going 300 miles per hour west. This makes it velocity when I add a direction to it. Okay? Now we do have a little speed velocity clip here. Let's take a look at it. Or not. I guess not. Okay, well, we will figure out where we need to go. We'll go back. There we go. All right, which of these are an example of velocity? A, 25 meters per second westward, 1,800 kilometers per hour, 55 meters per hour south, or 25 meters per hour. So which ones are examples of velocity? You should have said A and C because they both have direction. All right, so why do we care? Why do we need to know velocity? Well, it's important to know a storm's velocity and not just its speed, because speed tells us how fast it's going, but velocity tells us the speed and the direction it's moving. So, and here's an example of, a weather map, and here we are right there. So, if we knew that the storm was just traveling at 60 miles per hour, would that do us any good? No, we wouldn't know if it's coming towards us, if it's already past us, or what. But when we say we're sitting here in Findlay and the storm's over here and we say it's moving 60 miles per hour east, okay, we know that it's going to be hitting us soon and that we need to probably seek shelter. So direction is very important in terms of predicting and helping protect people when it comes to storms. Okay? Alrighty. Now, let's see if I can get that last clip up here. Let's see if we can find it. I'm going to pull up a different file here. Computer, let's go into speed and motion, and let's take a look at this guy right here. He's going to talk about speed and velocity related to skateboarding.
Hi, my name is Bill Robertson, and you might know me better as Dr. Skateboard. Welcome to Dr. Skateboard's Action Science, a video series where we explore the physical science concepts found in skateboarding and BMX. In this video segment, Motion, we're going to learn all about motion. Action sports, such as skateboarding and BMX, are great examples of motion. So let's get moving with motion. In order to provide a better understanding of the scientific concept of motion, we need to better be able to describe motion. Speed, velocity, acceleration, and momentum are specific concepts that provide greater depth in understanding and describing motion. While all these terms seem alike, they are actually fundamentally different when it comes to breaking down motion. For example, speed is a measure of how much time it takes an object to move or change position. Whether a bike, car, boat, or board, the speed of an object is determined by dividing the distance traveled by the time it takes to travel it. Likewise, velocity is a measure of how quickly an object moves or changes position, with reference to a particular direction, such as up and down or north and south. For example, if a rider comes down a ramp or inclined plane, the velocity is defined as the distance traveled by the time it takes to travel it, yet in a specific direction, in this case, east. So velocity is different than speed in that velocity requires a direction, yet both speed and velocity can be calculated using the equation v equals d divided by t. It is also important to remember the units of measure associated with the variables. Distance can be measured using centimeters, meters, or kilometers, while time can be measured using seconds, minutes, hours, or even years. For instance, let's see how you might solve a problem as it applies to a BMX.
Okay, so that ends our segment on speed and velocity. I'll see you in class.